AP Human Geography. In AP Human Geography, it's a flipped classroom. This means that you will take notes and view these video lectures at home, and we'll do more practice and application activities at home or in the classroom. This means that really the more passive form of learning, you listening to a lecture, you taking notes, you reading, you do that on your own. And I'm able to spend more time helping you with a lot more of the complex problems and the application of the knowledge in the classroom. The lectures are recorded in two formats. This is the PowerPoint format. If you're watching this video lecture, you should probably be taking notes either in a notebook or on loose leaf paper, or maybe filling in your reading guide with a little bit more detail as we go along. There's also the sticky notes video lecture. Sticky notes are notes that I use on Post-its. I annotate the textbook with you. No matter what type of note format you're using, no matter which video you watch, you should also be reading the textbook. The reading guides will be available posted on our Edmodo page, so you can print those and use them. You could use notebook paper, as I said before. And the other tool you'll have is your study guide workbooks that come with your textbook, and those feel free to write in. Just remember that using those reading guide or using those reading workbooks, which are really more of a study tool, they summarize the chapter and they give you practice questions, but it won't substitute actually reading the book. We'll be starting with Chapter 1, Key Issue 1. Unit 1 will cover Chapter 1 and Chapter 4. And Key Issue 1 will be covering the differences in early and contemporary maps. We'll talk about map scale, map projections, and how maps are made. We'll talk about latitude and longitude, and we'll look at contemporary tools like remote sensing, GPS, and GIS. So how do geographers describe where things are? Geography is the study of where things are on the Earth's surface and the reason for these locations. So in human geography, we ask two questions. Where are people and activities found on Earth, and why are they found there? So we're really looking at human environment interactions. This is different than physical geography that really looks at geology and landforms. You're probably most familiar with physical geography because you would learn a lot about that in Earth space science. And you might have studied a little of geography before this. You might have had maps or had to label like the countries and capitals of a continent or the states and capitals in the United States. But we're really looking at not just what places are called, but why are there people there? What activities are found there? Why? And we use maps. So cartography is the science of map making, and we don't really build maps in geography. We use them as tools. We use them as reference tools to show where something is, either its absolute location, usually using its latitude and longitude, or using its GPS data or GIS data. And we can also look at relative location, like how close are these places? Is it near the ocean? Is it closer to another country? And we also use maps as communications tools today. So we use them to show how human activities are distributed. The earliest maps were really more of reference tools, and they were there to show people how to get from one point to another. The first world map was prepared by Eratosthenes, and it was really cool. Like he was able to calculate the circumference of the Earth based on really just some geometry and some trigonometry. He really used a stick, like stuck in the Earth, and measured the angle of the sun at noon and compared that to the fact that there was no shadow at noon in another location, and calculated the distance, and then used that distance and the 7.2 degrees compared to 360 to calculate the circumference of the Earth, and he was pretty on point with it. Ptolemy later made some improvements to the world map, and then outside of Europe, most advancements in cartography were made by Chinese and the Islamic world, and in Europe, map making kind of took off again during the age of exploration and discovery. So this is a Polynesian stick chart that showed people how to get around. This is Eratosthenes' map, which isn't bad for what they knew of the world at the time. This is a later map by Ptolemy. And here's a map from 1571 during the age of exploration. And this map really shows you how to get around. It's pretty accurate, like I know that the North America shape is distorted and South America doesn't quite look like this, but it's really not bad for 1571. Today we use maps as more than just reference tools. We use them as ways to communicate complex geographic phenomenon. So these maps here kind of show you what happened with New Orleans during Hurricane Katrina. And so we can use maps to answer very advanced and practical questions. So we can use these 3 different maps to answer a couple of geographical questions. 1, is New Orleans a sustainably built city? And 2, why did Hurricane Katrina and the subsequent flooding affect people unequally? So if you look at the first map, it shows you the flood extent and the flood damage in New Orleans. And so the first thing you could ask yourself is, did the levees and dikes and canals and seawalls and pumps and all the things that we put into New Orleans to make it livable, since it's built upon basically coastal wetland and it's below sea level, did all of our fail-safes work? And if you look at the amount of flooding here, you could say no. The seawalls didn't work, the levees, the dikes, the pumps, all of those things failed us during Katrina, a large superstorm. The next question you want to ask yourself is, will it be sustainable? Is it in continued danger? Do you think these areas in New Orleans are safe today from another superstorm or safe from sea level rise? And this last week, a heavy rainstorm flooded New Orleans again. 2 of the 21 pumps broke and there was extensive flood damaging. So no, this is not really a sustainably designed city. We need to improve it. We need to make adaptations if people are going to continue to live there. And then you look over here in this map, and then you want to ask yourself, let's compare this map of the percentage of African Americans in each of these different communities to this map, and were people equally affected by the flood damage of Hurricane Katrina? And in some areas, you can see that less than 15% of the population was African American. But overall, look at these areas here. These areas that suffered from flood damage range from 75% African American to 41 to 75% African American. And so by comparing these 2 maps, you can say no, people were not equally affected as far as racial and ethnic backgrounds go. African Americans were disproportionately affected by flood damage in New Orleans after Hurricane Katrina. And this third map, if we compare the first 2 to this one, now we can say, how has Hurricane Katrina changed the population of New Orleans as a whole? This map shows you the population change since 2000. And so the green areas are areas where it's decreased. See the little negative sign there? So the dark green areas have decreased by 50%, the lighter green areas by 25%, and then by 10%. And the dark red areas and orange areas are areas where the population has increased. And you can tell by looking at that as a whole, the population of New Orleans and this area where the flood damage occurred has decreased since 2000. And you can see that areas that were primarily African American communities have decreased the most. So you can see that New Orleans really needs to make changes if it's going to continue to be a sustainable city in a world with sea level rise and superstorms. You can see that people in communities that were primarily African American, those communities changed the most. They suffered the most flood damage as a whole, and those communities have shrunk. They become smaller as a whole. The next thing I'll talk about is map scale. So the level of detail and the amount of area covered on a map depends on its scale. And this is the relationship of a feature's size on a map compared to its actual size on Earth. And you can look at map scale as a ratio or a fraction, which you've seen. So in this case, maybe 1 inch equals 24,000 inches. You can also see it written out. So 1 inch equals 1 mile. A written scale is written out in words. And a graphic scale is like the little measuring bar at the bottom of a map. And you can use that little bar line as a measurement. So you can take a ruler to it and measure how far something is on a scale. So this map here has both a ratio scale and the graphic scale. So here it tells you that 1 inch is equal to 10 million inches. So this is a small scale map because this number is really, really small. And the detail you see is small. It's really zoomed out. If you wanted to see how far this point was from this point, you would use the graphic scale. And then as we zoom in, the scale gets larger. See this number, if you divided 1 by 1 million, that's a bigger number than 1 by 10 million. So this is a bigger scale map. And you can see more detail. Same here, this red area, Central Houston. So now we're looking at Central Houston area. And the area that's in red here is basically this image right here, Minute Maid Park. So each red box is the blown up area for the one below it. This number is bigger than this one. You can see more detail. And this is the biggest scale map we have of all. 1 inch is equal to 10,000 inches, and you can measure the distance using the graphic scale there. When we take maps, all maps have something called distortion. So projection is the way we take the spherical shape of the Earth and we project it onto a flat map. And any type of projection leads to distortions. There are 4 main types of distortion. The shape of an area can be distorted, the distance between points can be bigger or smaller, the relative size of different areas can be altered, and the direction between points can be distorted. So whenever you're taking something round, like a point on the Earth, and putting it onto a flat map, you're going to have distortion. So this is the Mercator projection, and its biggest distortion is in the size of these continents. And its distortion gets bigger at the poles. So Antarctica, definitely bigger than it really should be, proportionately. And Greenland is not the size of Africa. It's way smaller. But the Mercator projection is great to help you travel this distance here. It's a great ocean map. The good projection would be horrible for ocean travel because it really makes this point look like it's way bigger than it is because of how they've divided it. But Greenland is the right size, and so is Antarctica. The Robinson projection has Greenland the right size, Antarctica's about right, but there's some shape distortion overall and some distance. Robinson is pretty. It's not always the most accurate map, but it's very attractive. I think it's a very pretty map. We'll talk more about projections in class. The geographic grid, you should know already, is latitude and longitude. Longitude is going from the North and the South Pole. So 0 would be the prime meridian, and then you go 180 east or west. And then your parallels are your lines of latitude, like flat lines, and they start 0 at the equator, and they go up 90 degrees north and south. So here is your latitude. I would think like flat lines on a piece of paper. And here's your longitude. And you should be able to use the numbers provided to you to find a location. So this is about 25 south and probably about 59 west, and you'd find Buenos Aires. So by just using basic graphing abilities, you should be able to find a location based on the latitude and longitude. The geographic grid, again, you can find places by using your latitude and longitude intersections, and we'll do some practice with that in class. We tell time based on our degrees of longitude. So you can divide 360 by the 24 time zones. Each equals about 15 degrees of longitude. Greenwich Mean Time is located at the prime meridian in England, and it's the reference point for time. The international dateline is at 180 degrees longitude, and that's when you either move back or forward by a full day. And you should be able to calculate time by using this map. And so if you were traveling from New York to Los Angeles, you kind of lose 3 hours. So if it's 3 o'clock here, it's noon here. If you're traveling from New York to Paris, you would jump ahead. So if it's noon here, it's 5 o'clock here. When you travel, it gets really cool. So when I left from Florida this year and I went to Panama and then to Ecuador, I lost an hour and then went back to my original time zone. When I flew to China a few years ago, I moved up a day, and then I landed back home a day before I'd actually left China. So that was probably the coolest. As far as contemporary mapping tools, we have GIS, or Geographic Information Science, and this involves the development and analysis of data about the Earth, and it's acquired through satellite data. We collect data using remote sensing, or using satellites, essentially. And we can use remote sensing to basically build a map. When we pinpoint locations, we're using global positioning systems. So GPS has to do with where something precisely is. So it can give you directions, like on Google Maps, and it can provide locations, like when you're playing Pokemon Go, or when you're, ordering food, and they're use my nearest location. And then GIS is what makes the actual maps, and so it's usually layered data, and so you get vector data, and you get something called raster data. So vector data is a location of, in this case, cities. Vector data could also be the location of the